Hi, I'm Tony Poulos, and today I have with me two very distinguished guests. Grant Lenahan, who is a partner with the Appledore Research Group, and Chris Purdy, who's CTO of CENX. Gentlemen, I've been wanting to get hold of you to find out a lot more about NFV, or Network Function Virtualization. Look, firstly, what do you see the implications of NFV on operations for telcos? Grant, would you like to kick me off?
Let's look at this from two perspectives. The goal of NFV is really not around technology. It's around agility, and it's around dramatic cost reduction. The challenge that we're seeing is if you're not careful, you can actually drive up complexity and therefore drive up cost. And we're looking at a lot of architectures and best practices to avoid that.
Yeah, there's no question that by default, if you just introduced NFV and you didn't examine all of the systems around automating the processes and making it work, you're actually going to increase complexity dramatically. There's a whole bunch more failure modes that can occur because your failures in your compute, failures in your storage, failures in your network can then impact the VNF itself rather than the network element, which was all contained in the past.
But how can we simplify something that appears to be so complicated? How are we going to get around that?
If you look at the way operational support systems were done in the past, where you have siloed implementations across domains, is fundamentally the wrong way of looking at it. And I think the first thing that you have to do is understand the abstractions that take place in a network, which is really network domain by network domain, and now these new NFV domains. And you've got to build control loops on a per domain basis, and then federate those various control loops based on the services provided from one domain to another.
Grant, do you want to add to that?
We're seeing something very interesting. We just published on control loops, ironically, and the mantra that we had in the report was to think globally, but act locally. And that you really need to enable an SDN domain or another domain to be managing itself. That's a key element of simplification. You're not boiling the ocean. Another key element of simplification is to learn from other industries. Control loops and this sort of automation isn't new. It's new to our industry, but it's why planes can be automatically flown. The military uses it for ballistics control. It's the only thing that keeps transistors stable over temperature. And we can grab those best practices and say, how do you apply them? And one of the simplest best practices, since we don't have time for a lesson on it, is there should be one control loop. So don't totally build out a new assurance function. Take the kind of learnings that you can get, the way that CENX looks at it, and bring it back to the same orchestration system so that you have consistency, less code, a lot of simplifications in your process.
There's no question that what happens when you add complexity, there's so many complex systems out there. And it's that notion of acting locally of small control loops and then larger control loops within that at the domain level, and then ultimately control loops at the service level, that's hiding complexity. That's what telecom has failed to do in its operational support systems in the past. But many other industries, as Grant said, have absolutely adopted. And I think that's one of the critical different ways of thinking in order to address NFV and actually make it successful.
Well, I understand all of that, but we're talking about networks that are going to be changing virtually constantly, all the time. How are you going to manage those changes, even with NFV, through these closed loops and the controllers? How is it going to be done in a dynamic sort of environment?
Chris earlier was indicating that things could get a lot more complex, and if you don't use automation, it's going to get out of control. I think one of the simplest things to think about is that with NFV, you can have pieces of a network function moving around all the time. It's actually impossible for human beings to manually keep up with all of that. So we need to have A, automated systems, and B, think about inventory for a moment. Now we need a topology that's dynamically tracking this NFV as it moves around so that you know what the underlying cause is and how to rectify it. And actually, Chris has real experience building these systems. I live in the world of theory, he lives in the world of practice.
Yeah, I've built a lot of operational support systems in my day, and one of the basic paradigms of building operational support systems was based on the fact that these were physical networks, and so they didn't change very often. And so your whole information models and how you maintain them was designed for that. NFV is introducing this ability to create virtual network functions and instantiate them in real time at the click of a mouse. And with that comes just a different way of thinking. And so a lot of your existing operational support systems are not going to be able to be migrated to the new world just because of that fundamental shift.
And that raises my next point. We talked about operators now having siloed, operation types and things. How are they going to simply, take on NFV? How are they going to prepare to take on NFV? What's the process they have to go through to prepare for that?
Grant and I were talking earlier that the first thing everybody talks about is the fulfillment side.
Yes.
And so there's been a tremendous amount of work at NFV and in all of the various standards bodies and a lot of the proof of concepts around how you instantiate a VNF and how you scale a VNF up and scale a VNF down, etc. Or how you make a VNF part of a physical service and connect it through. I think a lot more people now are starting to recognize there's another huge area that once it's up, how do you assure it? How do you make sure that it's actually performing adequately? What do you do to maintain it? And that's where the other end of the control loop comes in, where you're actually monitoring the performance of this in order to feed back to the orchestration systems to make the changes. And I think that's a big area where now I think we're seeing the service providers starting to think.
Well, and how are companies like CENX helping to do that? Are you part of that process? Is that what you're doing?
That's our main function. So we're not in so much in the fulfillment side, where we would work with those orchestrators that are doing it. Our mission is to be getting that dynamic topology and maintaining that topology dynamic in real time. Take in all the real-time data that's coming and analyze it to determine whether or not it's actually performing as per the standard, and then feed back into the orchestration. And that's the closed loop that we feel we are part of.
And Grant, there's no quick way to do that, is there?
It's best to move in stages and get it right. But one of the things that we're finding is initially when we were talking to suppliers and operators about orchestration, like Chris said, their first goal was get things set up and running. Now as they're coming back and they're saying, now how do I assure it? They've got two questions. How do I implement the kind of real-time intelligence that Chris is talking about? In Appledore Research Group, we call that real-time automated service assurance, or RASA. What we are finding, though, is that places a new set of demands on orchestration. And it's almost like orchestration version 1.5, where we're now looking at orchestration vendors and the deployments of CSPs and saying, do you have the right level of policy control and parametric modeling so that you not only can set it up, but when CENX's magic box says, I need the following fixed, I need the following damaged components taken out of your solution set for an answer, redo it, they have the ability to take on board that critical thinking and do the healing or do the scaling to bring the service back.
And it's absolutely essential that the same element that's actually configuring it the first time is also the one that's doing the reconfiguration.
Yes.
That's why the control loop works. Is that, like, if a ballistic missile was fired a certain way and you measure that it went too far, you've got to use the same gun, or else you're going to miss again. And I think that's my other analogy is, it doesn't make sense to have two steering wheels on a car. Right? You really have to have that.
I do get a little worried when you guys start talking about guns on networks, but there you go. Thanks very much for your time today. At least I understand NFV a lot better. Thanks very much, Grant.
Great seeing you, Tony.